guys.
Hello.
What's up, everybody?
That music really hyped me up.
Yeah.
That it always surprises me how hard that music comes in.
How's everybody doing?
I'm doing good. Yeah. How about you?
Good. Maybe we can just do a round of intros. I know Harsh and I are doing this for the first time. David, why don't you go first, since everybody already knows you? Okay.
My name's David Myhall. I'm a senior architect at Fuel. What else to say? Very excited about predicates. I'm fresh off a flight, so I'm a bit jet lagged, but super pumped up to talk about predicates. And yeah, I think that's about it. You want to go next, Harsh?
Yeah, sure. My name is Harsh. I do R&D at Fuel, and I guess I'm pretty excited for the stream as well because one of the first things that I did with Fuel before even joining it was that I was sniping some funds at very common predicate codes that I kind of figured out, and that was kind of my introduction to predicate. So, yeah, pretty pumped for the stream as well.
Awesome. Well, hi everyone. I'm Sanya. I do research marketing at Fuel, and I co-wrote the article on predicates and scripts that we're going to be talking about today. Super excited as well to discuss predicates. So yeah, why don't we just get right into it? I'm going to be moderating. Sorry, go ahead.
Oh yeah. I thought that you wanted someone to get into it, but go ahead, yeah.
Always ready, yeah.
We're all going to get into it.
We're all super excited. So yeah, I was just gonna say that why don't we start from the very basics? Predicates are a pretty technical topic. I know a lot of our users have confusions, misconceptions about them. So I think it would be really great if both of you could just kind of define what predicates are, maybe a real life analogy or something like that, just to make it easier to understand.
I've got a metaphor lined up. I feel like predicates it's always hard to come up with a good explanation, even though I think they're quite simple. So I don't know, I'm curious to see what your explanations are. I can jump in with mine to kick things off. The metaphor I was going to go for is, ultimately predicates are a type of an account. And in blockchains, what an account does is they're what lets you unlock your funds, basically unlock the ability to transact on the chain. So my metaphor is that a typical account on a blockchain, it's kind of like a normal lock to a house. You put a key in, there's one key, there's one lock, you can unlock the house, or you can unlock a safe, to be a better metaphor. And a predicate's kind of more like a smart lock. I've seen there's electronic locks where you can maybe there's a screen, you can put in a passcode, and maybe over the internet somebody can unlock it as well, and there might be different settings and things like that. So it enables much more things. That's kind of the metaphor. I don't know, does that land? What do you guys think of that metaphor?
Yeah, I guess it's kind of how I think about them as well. For me, when I first saw them, and I guess for me it was okay, what's the difference between it and a smart contract? Both of them look exactly the same. But then after spending a lot of time on it, I kind of figured out, oh, so it's basically a program. And this program has capabilities that it guards some amount of assets, just like how a private key guards some amount of assets for a user. But what it allows you to do is to write any kind of complex spending conditions that you want for an asset. So when you are on a chain like Ethereum, unless using a smart contract account, the only way to spend your assets, if behind an address whose private key that you know of, is just by digital signatures. But predicates allow you to have that plus something more, where you could write any complex spending condition. I could say, I could just build a native multisig and say some funds are locked here and only move them if X has happened, or if X and Y and Z are true. So I just look at them as a way of getting more complex spending conditions for your assets.
So can you give me an example, maybe using two parties that are trying to send assets to each other? How would it work with predicates versus in a more traditional sense, the smart contract, for example?
Yeah, so one of the coolest examples that, and this is something that when I also like got into Fuel, and while I was chatting with Nick, I realized that okay, this is really epic. Was when I was realizing that okay, let's say two people want to do a like a peer-to-peer swap, and let's say I am on the EVM for now the way it would happen would be that right now I will either send my funds to you and you will send some funds back to me, and the only way to make it happen atomically is that we would firstly deploy some sort of a smart contract on the EVM that would take custody of your funds, and then I would have to go and take custody of it would take custody of my funds, and probably we would need a third transaction which will like send my funds to your funds and your funds to me. But with the predicate, what you could do is that let's say if you have 100 USDC and you want to exchange it with some ETH that I have, you could just lock it behind a predicate address, and all this predicate that would do would be that it will look that whoever is trying to take your 100 USDC out from this predicate is providing certain amount of ETH back for it. So for example, we could hard code it to 0.1 ETH or anything like that. So you just have to deposit once, and now you can sit back at your home in Dubai and know that okay, like the only if funds have moved out of this address, then the only way it has happened is that if someone has sent me back 0.1 ETH on my address. So yeah, that's like one way of one really cool example of like designing spending conditions with predicates.
So basically, it makes it faster and easier to, and also more secure, I guess. To
Yeah,
send
more
it.
secure. Yeah, because
But
when you
yeah,
Mhm,
go
go ahead.
ahead. No, go ahead. Go ahead.
Oh yeah, I was saying that because let's say someone could argue that oh, you could technically do it with a smart contract as well, but then the argument would be that a smart contract can access a blockchain state and could, in theory, be later on upgradable. Of course, you can track that, but with the predicate, it's defined. You cannot upgrade and predicate. Every predicate has a unique address, so it's like way more secured way of designing spending conditions than just smart contracts.
Gotcha. Okay, that kind of makes sense. So then, what would you say differentiates predicates from something like accounts or intents?
Mhm. Yeah, good question. I would say like so from a normal EOA, which is an externally owned account that we have on Ethereum, there's only one spending condition that exists there, and that is that unless we get EIP 7702, but till now how Ethereum has worked is that if you have an EOA and normal account, you have a private key which controls the account, and there's this very one specific way on how you can spend your assets. So the only way to spend my assets here is I would firstly do a digital signature over it, and then that's it. That's like on the only one way to do it. But predicates make it flexible, so you could say that this particular user experience of signing and spending is a small subset of all the experiences that a predicate can provide. So in this scenario, like it could provide an account like scenario where you just sign over something and all it checks for is a signature. But then you could also go really crazy out with it. You could say, I want to make sure that like some 1,000 people out of 1,000 people, 950 people have signed over it, and then you could compress it using a zk proof and then verify the zk proof in the predicate in constant time, and you have a very complex multisig which can scale to thousands of users, and you could just design like various complex kind of wallets. You could have a wallet that could work on top of face id, you could have a wallet that could work on google sign-ins. So you can design all sort of smart contract accounts without using smart contracts, which would be inherently safe, and which the developer can just not decide to upgrade one day. Like the logic is like written in stone, cannot be changed. So that's the difference here.
Is it expensive to use predicates?
No, actually, I would say not much. Like the good thing about them is that they're not deployed, so you just provide their bytecode. So, for example, right now when you use a smart contract, the step one of using a smart contract is deploying the smart contract. But when you're using a predicate, you provide the predicate bytecode directly over as part of a transaction. So it's not deployed, it's directly executed, and it's very cheap. Like it does not have any state, it does not update any state. So it's pure execution, and execution on FuelVM is really, really cheap. And with the new opcodes that are coming to Fuel, like the ZK opcodes, you could design ZK accounts, which is basically you could run some super complex computation, which could take, let's say, more than 30 million gas, which is the current Fuel block gas limit. But you could verify all of this in constant time. So yeah, they are cheap, and then there are also tricks to make them even cheaper.
So you're telling me it's super secure, it's fast, and it's cheap. What's not to love? Like, are there any like limitations with predicates?
Not that not that much that I have seen. Like the only one that I would say, but again, that's a security feature. I won't even call that a limitation. Is that you cannot access the state, so you cannot be dependent upon the state. But that's not like a bug, but that's a security feature consciously chosen while designing predicates. So yeah, I would say that yeah, like they're really cool. They are fast, they're secure, and they're very simple by design. So I guess that's like one of the things that I really love about Fuel. For say, yep.
David, I was just asking Hirsch about some of the limitations with predicates, because to me they just sound like the perfect solution. Like, it seems like they have everything. They're cheap, they make things more secure, they're fast. And I just asked Hirsch about any limitations with predicates. Do you have anything to add? Is there anything that maybe he missed?
Yeah, I mean, I didn't catch all of Harsh's answers, so my internet dropped off, but there are certain limitations. One way I think of it is like a smart contract can do anything a predicate can do. Smart contracts can actually do much more than predicates, because smart contracts can call other smart contracts. They can store data, things like that. Predicates are kind of, they're very simple in some ways, but really what it does, it unlocks all the performance that I think you've talked about. The ability to only need to kind of validate a predicate once, the ability to kind of process them in parallel. So yeah, but the main limitations would be like if you're used to writing smart contracts, you're like, oh, I'm just gonna have one contract call another contract and check something. You can't do that in a predicate. Or I want to store something, right? Like, okay, I'm just gonna like write this data. I want to like update a balance, or I want to like store some arbitrary piece of data. You can't do that easily. Now, you can use UTXOs in an interesting way where you can basically unlock some sort of state, but that's a very different paradigm. That's the part that's really like a major mind shift from the smart contract development.
Yeah, so I like when I was new to Fuel, like I was thinking about same as well, like the limitations behind predicates. But then what I came to the conclusion was that it would have been very bad if you only had predicates, right? Because then there's a lot of stuff that you cannot do. But then I kind of realized that if you're getting into a land while designing your solutions where it needs to be stateful and it needs to interact with a bunch of other programs, probably what you need is a smart contract. So I guess yeah, like yeah, so I guess like for me, like I've always thought these things as not to be like limitations in the sense that they would limit of what you could design on Fuel. But I always thought of them that okay, like if you're coming or running into these things, probably you need a smart contract. But yeah, probably David could like uh, let know as well. Like, do you think, David, there is something where some sort of a use case which lies in the category that okay, if this was on, let's say if this one feature was on a predicate, then like they could have been better. So for example, let's say this use case would only make sense if this one feature is also in a predicate, and like, and it just, it's not, if it's not done in the smart contract way, it's better.
Sorry,
I
my internet
guess.
cut out one more time.
Yeah, I guess like I guess now you're back.
What was the
Yeah, I was
question?
saying,
Yeah.
yeah, I guess my question was, to simplify it further, was that let's say for me, like every time I think about predicates and the limitations around them, I've always come to the conclusion that okay, if you need like stateful design and everything else, probably what you need is a smart contract. And what you're trying to design is kind of not ideal when designed around a predicate. But I was thinking that, have you ever come to a use case where you think that, oh, this should ideally not be done in a smart contract, but it's ideal for an predicate, but then there is some limitation in the predicate which doesn't allow for it to happen?
Yeah, the way I think about it is that predicates are obviously like really good for things that are very stateless. So a good example of a really like stateless type of application would be new types of signatures for an account. So people we use predicates for like the MetaMask predicate, the EVM predicate. So you can use your EVM wallet. You can use your Solana SVM wallet. You can use different types of curves. Those are totally stateless because the logic is just checking like a different signature scheme. Then you get to something like a multi-sig. You can have like a really basic multi-sig where it's like, okay, it's like a 2 out of 3 multi-sig. But say you want to be able to change the signers on that multi-sig. Now that is state. That's like the ability to say like which address is a signer and which is not a signer. I want to add and remove. That is a type of state. And what we can do is we can do that with UTXOs. And so I believe this is how Baco, the main like multi-sig on Fuel works, is that there can be some UTXOs minted, and depending on the either the location of those UTXOs or the asset ID of those UTXOs, that can represent some state, and a predicate can read that data. And I think kind of our goal is to, using this technique of having predicates combined with UTXOs, we can do more and more complex types of stateful applications. And the goal is to have like a Uniswap that's just built with predicates. It's something that we've discussed internally a lot. I think Harsh, you and I have talked about it. We've talked with Nick. That's something that would require a bit more complexity. It requires kind of a block builder to kind of order transactions in a certain way and kind of keep track of that state off chain. So it gets very complex. It's a very different paradigm than how we would traditionally build things. But if you assume that you can do that type of thing where like a block builder can track state and rehydrate state, as we call it, then you really could build, I think, any type of application using predicates. So, but it's certainly like, we're not quite there yet. We're not really building Uniswap with predicates, but I think it's really like cool future to aim for. And it's really like, I don't know, it's an exciting idea.
Yep. I see. That makes sense. Yep.
I don't know what's going on with my camera. Weird.
Yeah.
Okay, so I wanted to talk more about some of the misconceptions that are often associated with predicates. What are some of the most common, non-facts that you've heard about predicates?
That's a good question. Yeah, I've seen people confuse them a lot with smart contracts. So I've seen that happen a lot, at least in my experience, where someone would try to use storage operations in predicates and wonder why they're not working, or someone might try to come up with questions why we cannot call other smart contracts. So I guess the common misconception that I've seen people get into around predicates is confusing them with smart contracts, where they think that it is some sort of a smart contract and has smart contract ability, but is somehow completely deterministic. So I think that's a misconception. I would say that predicates are more of a subset in terms of features of what a smart contract can do. So everything that a predicate can do to some degree a smart contract can do, but then not everything that a contract can do is something what predicate can do, and both are very different tools. So it's like you would use predicate as a tool for a completely different use case ideally versus what you would use a contract for. And ideally there's a world where I think we could completely ditch smart contracts with state rehydration that David has been a huge supporter of. But I guess right now in the current world, they're two different tools and for two different use cases.
So just to clarify, do we not use smart contracts at all in FuelVM then, or are we like, do we have them right now and we're trying to get to a point where it's all predicates and no smart contracts?
So we do have them right now, But I guess like on where do we want to get from here, I think David has a really, really good picture of, like where we want to get with state rehydration and all of that stuff. So I would let like David speak on that.
Yeah, I would say like right now, most of the applications, Mira and Swayland and things like that on Fuel are kind of like Ethereum style applications. So they're built with the code of the smart contracts is pretty similar to how you would build the same. I'm gonna turn my video off.
Yep.
You guys still hear me?
Yep.
Yeah.
Okay. Yeah, so that we're building things that are pretty much the same way you would build them with Solidity with the EVM. There's a few things that are using predicates, like I mentioned before. Like the main things are the different types of accounts. So like the EVM wallet is using predicates, the Solana wallet's using predicates, Baco's multisig is using predicates. And I think there's been a lot of talk about using predicates for order books. So that's I'm not sure how many of those are in production yet, but that's certainly something that can build with predicates. And then I think the goal is to move more and more applications to build them like the Fuel way, which is obviously kind of hard, both from like a conceptual point of view that you have to change the way you think, as well as from like there's definitely just some tooling and some infrastructure that needs to be built out, and that's kind of a lot of the stuff that we're working on building now. Make sense?
Yeah, makes sense.
I can also touch on kind of Sonia, you asked before, like what are common misconceptions around predicates. One that I've heard is people have asked kind of like I guess there's two similar things that are related that I've heard. One is are predicates can you spend a predicate? We'll talk about like, oh, like I'm going to create a predicate and I'm going to spend a predicate, which I think doesn't make a lot of sense because predicates are neither created nor destroyed. They're just a hash. They just kind of exist. And then the other kind of related thing is people kind of comparing predicates to intent, saying the predicate is a form of intents, which there's some similarities, but they are quite different. So I can talk about kind of those there. So again, a predicate is just an account, and accounts are not created nor deleted. In the same way, like a normal private key predicate, it's not created or deleted. It's always there. It's just only is created essentially when like send assets to it. So this is different than a smart contract, where a smart contract is actually created. It gets on the blockchain. And in terms of like intents, I guess that's not a metaphor. It's a simile that I've used is like transactions are to intents as accounts are to predicates. So an intent is kind of like a very generalized, abstract, kind of more general purpose version of an action. A transaction is very rigidly defined. It's like I'm going to sign a message saying exactly what function I want to call. Whereas an intent is like, oh, I'll sign a message saying like I just want to do a swap and I don't really care how it's done. And a normal account is like a hash of like a public key, and you can kind of send a transaction from that account if you sign a message with that private key. A predicate is like a more generalized programmatic way of saying like it's just a bit of code. Like it can execute any type of logic. You can validate it with a private key. You can validate it with multiple private keys. You can validate it with some other asset-based logic. So it's really like a general purpose version of an account.
Yeah.
Gotcha.
I guess like just to add that when the first time I heard that predicates are neither created nor destroyed, I was like, what does that even mean? So I kind of agree because it sounded like it sounded like a line from some Hindu scripture, like some like some really philosophical line that they are neither created nor destroyed. But then it took me a lot of time to grasp that, that like these like every time you use a predicate, you send the code of the predicate along with the transaction. So if you're a developer, like this is something that is really intriguing, which I haven't seen in other chains yet. So yeah, something you should definitely check out.
Okay, I wanted to dig in a little bit deeper into the whole security aspect. Harsh, I'm not sure how much you can share with me about this, but I was just curious about what security considerations are like unique to the predicate model versus traditional signature verification?
Mhm. So I would say that, let's say, traditional signature verification versus traditional signature verification on a predicate, it's pretty similar. Now, what makes a predicate really interesting is that if you have parked your funds behind a bunch of FuelVM bytecode, there's a guarantee that comes with the predicate that the developer of the predicate cannot change it, right? So it means that whatever spending conditions you are signing up for in a predicate, the developer cannot one day decide that, oh, now I see that some $50 million are parked here and a bunch of people have believed in me for quite some time. Let me now issue an upgrade and let's just change the code of it. And a lot of smart contract code these days is upgradable. So I would say that is something that is really, really cool in terms of security about predicates. That if I sign for X, then there is eternal guarantee that only X can happen. And someday someone cannot change what I signed up for. It will only be those pending conditions that I signed up for. So that's where predicates get their security from. Second thing is that they are deterministic, which means that if, let's say, uh, I give you some inputs and I show you that if you have these inputs, you will be able to spend from my predicate account, then since they are deterministic, it cannot be that if we do some business exchange among us, then post some time it won't be true anymore. So that is something that is really cool about them. They're deterministic. If given some inputs, they return true, then regardless of how many times you will execute that predicate, it will return true. So I would say these are like the two really interesting security guarantees that come with them that makes them really unique for parking your funds and like designing various spending conditions with them.
Cool. David, did you want to add anything? I asked Hirsch about security considerations that are unique to predicates versus traditional signature verification.
Yeah, no, I think Harsh covered it pretty good. I think it is still similar to smart contracts. Like they get the immutability of the blockchains that smart contracts do as well. And, just like smart contracts, you can kind of introduce types of mutability. Like there can still certainly be conditions that change. You can have security issues. So I wouldn't say they solve a ton of security issues, but they do offer a really nice property of this like deterministic account that kind of exactly like at least what the base code of a predicate is. One like security thing, this is maybe a bit different than kind of what you're talking about, but I think it's a cool application of a predicate, which I think makes sense in the concept of security, is an idea that we've discussed is the idea of using predicates for asset transfers. So one problem with blockchains in general, like think about when you're transferring someone money, you go to like send some crypto, especially if it's like a large amount. Sending crypto is really scary because you copy this like long piece of hexadecimal data and you just hit send and you hope you copied it right. You know that if you copied it wrong, if you made a mistake, if you send it to a transaction address or an asset ID, then like the funds are just gone forever. One idea that hasn't really been implemented yet would be to use a predicate where instead of sending funds directly to a user, you could send it to a predicate that would basically let the user either accept that transfer um, or they could cancel the transfer, or the sender could cancel the transfer. And I would love if Wallet starts supporting it so that if I'm like sending someone money, I could like send it, and then if I'm like, oh man, I sent it to the wrong address, I sent it to an address that doesn't even exist, I could just cancel that transfer and pull it back. And this is something that you can kind of only really do with predicates because what the predicate would be is you would have a predicate that's basically says like the recipient can accept the transfer or the sender can like cancel the transfer. And it'd be a deterministic address you calculate. Now, again, you could do this with a smart contract, but that's just so much more complex if you had to like deploy a smart contract for this, or you had to use some smart contract that's storing all these like pending transfers in state. So I think that's just like when I think of security and predicates, I know that's I think a bit different than the question you asked, Anya, but it's something that came to mind as like a really one of the types of like applications that's unlocked by predicates.
So are you saying if I sent you 5 USDC and then I decided that I didn't want you to receive it anymore, I could just cancel and then it just comes out of your account?
Unless it wouldn't come out of my account, it would be like, you know, the way this would work is like my wallet would show like, hey, like Sonya's, you have a pending transfer from Sonya, like, do you want to accept it or do you want to cancel it? And then if I don't know, I think if you send me $5, I'm going to accept it. But if you beat me to it, you could cancel it and bring it back. Now, again, this is something that's just an idea, but like, I think things like that are things that can be really nice for improving the user experience of blockchain. So I'd love to see that. Those types of things used.
That also makes me think that like predicates then are really ideal for pull payments. Like every time you want someone to pull money from a vault or any kind of thing that you have, like they seem really ideal. Given the example that David shared here, where like I could just park money in a predicate and say that okay, I have parked 100 USDC, and anyone who can give me either 0.1 of X or 0.2 of Y. So any combination of these assets can take them off. And that's just like one interesting way of, like doing a swap or doing just a peer-to-peer exchange. So I think, yeah, like they are like really ideal for places where you just want someone to be able to pull payments based upon some conditions.
Yeah, and that's exactly what a limit. Oh, sorry.
Oh, go ahead.
No, I was gonna say we talk a lot about like one common application for predicates is like limit order books, and that's exactly kind of how a limit order book works. Is like you're able to pull money. You know, I say, hey, like you can take and I'll put a bunch of USDC here. You can take any of that as long as you give me the appropriate amount of.
Yeah. I was just going to say that I feel like something like this would reduce my anxiety while carrying out transactions by so much. I'm always, like, to this day, even if it's like literally the exact same address, I will still like quadruple check because I'm just so paranoid about losing all my funds.
Yeah, but by the way, like I was also wondering that, like just then based upon the idea that David shared, like it could also be a really cool way to do airdrops where let's say like a project does an airdrop and all airdrops are behind predicates and people who are active can go and pull the money in, but then they will do a scan post 1 month of whoever didn't even touch, let's say, these predicates, because probably now these are dead accounts, like it's been 2 months, 3 months and no one has even claimed. They could just claim this token back rather than like just directly sending those tokens and those tokens just going into void, like
yeah, we did. I remember, I think it was with Cam and maybe some other people. We spent a bit of time thinking about what would airdrops with predicates look like, and are they actually beneficial? Because of course, one challenge of an airdrop, like a traditional like Merkle airdrop, is those are stateful, right? You have to because you can only claim your airdrop once. So whenever you claim your airdrop, you need to like mark something in like a mark that this leaf of a Merkle tree has been claimed. So, you could do that with Merkle airdrop. You would have to, I mean, I guess if you're doing a Merkle airdrop, then you need to like send some coin to some address to kind of like update the Merkle tree. Or you could do, maybe this is what we were like kind of getting at, Harsh, is like you could make one predicate for each address that exists. So instead of having a Merkle tree, you just say like, look, it's fuel, like it's really cheap. I can do like 1 million transfers. Send, if I want to airdrop to 1 million people, I can send it to 1 million people. But instead of sending it right to their wallet, I can send it to a predicate where they can claim it. And if they don't claim it within, maybe they don't claim it within like 30 days, then the sender can like back those.
Yeah. That would be really cool. Like, and yeah, I guess it will be interesting to experiment with, like some project trying to experiment with their airdrop with predicates. And another hidden advantage of them would be that like the claim process would be easily parallelizable. So right now, let's say if the way it's done is that it's a single contract and it's stateful, and everyone is trying to, like touch the same contract. So these transactions have to go sequential. But if you go and do the airdrop with predicates, since each of them is behind a unique predicate, like thousands of people can claim in parallel, because these predicates don't conflict with each other.
That would actually be really cool to see. I would love to see someone do like a kind of like a demo or a load test of that, because I think one of the most common times we see blockchain congestion is when there's an airdrop, right? Like some team does an airdrop and there's one smart contract with one Merkle tree, and everybody needs to kind of like call that same contract. And on an EVM chain, it's like everything is already processed in serial, so that's obviously going to add a lot of congestion. But even if you built the same thing on, like, say, Solana, you have a Merkle airdrop on Solana, Solana is famous for being parallelizable, but if you still have one Merkle tree, like one, kind of Merkle root to update, that's still, you still might have a lot of congestion around that. So this would be a cool example of it. Can we have 1 million people claiming an airdrop at the same time and still get like that parallelization and still be able to kind of like push those through?
And if you think about it, right, like the way Solana's, so correct me if I'm wrong, but now when I think about it, like one thing that makes Predicate really unique is that, for example, every time you go and create a token on Solana, firstly you have to create a mint account for the token, and then every account has like a separate account for every token, right? And then there's a lot of other, like metadata around it, which is stored permanently per token. Of course, they have rent out there with it. But with predicates, what is really cool compared to even with, let's say, smart contract accounts on other chains, is that you don't have to deploy the bytecode. You provide it over bandwidth. So like locking, I could have the most complex predicate code behind millions of addresses, but the footprint on chain is similar for regardless of whatever the complexity is. So I think this is something that makes them really powerful here.
Yeah, that's a good point. And like, I don't know if we've touched on this much. I don't know if you guys mentioned this when I was offline, but like state growth is one of the really, well, it's a very key problem that really all blockchains face, and predicates are one of, I think, kind of the only solutions. Like we haven't, whether it's Ethereum or Solana or chains, like not many projects have any real approach to state growth other than like, some optimizations are in the trees and stuff. Predicates are like the perfect way to solve state growth, because as you said, like you don't need to store the code on chain. You don't really store like individual state. You can kind of use UTXOs a bit, and UTXOs are much lighter in the states than like a state tree. So if you want to do a lot of complex stuff, you don't need to like fill up everybody's hard drive by all these good programs and everything. It's like, you basically show the code for predicate when it needs to be done, when it needs to be executed, and then after that transaction is done, the chain can basically forget about it, and the network isn't like holding the burden of these programs.
Actually, I wanted to ask about the stateless thing. So then let's go back to our example of maybe I'm sending you, I don't know, like 5 USDC. If like 6 months down the line, I really want to track down like this transaction because this 5 USD is like super, super important to me, then is all that data just gone? Like, or is there still some sort of digital trail that I can follow?
So the trail's always there. It's part of the history. So when we, talk about kind of the different types of storage in a blockchain, the most important piece of the blockchain is the current state. The current state of the chain is what is your token balance, what is your debt to protocol, what NFTs do you hold. Every node in a blockchain needs those states, because if I'm going to transfer you 5 USDC, I need every node to know that I have 5 USDC. Then there's the history. The history is all the previous transactions. And the chain basically does need that to be stored in some way so that it can be replayed up to a certain point. So you can fetch the most recent kind of transactions from data availability. Ethereum only stores like 2 weeks of data availability. So to go back further, you'd have to, look at a more like archival spot of data availability. So that data is out there. It's not lost. You maybe don't have the same cryptographic guarantees. And then like the last step of storage would be like archive state. So this is something you can basically generate. If I want to know like what was my token balance like 2 months ago, the only way you do that is by running a node that basically checkpoints every block, every transaction, all the state there. So yeah, that history part is where it's where you'll see which transfers happen, which changes were made, and it's where if you want to get like the bytecode of a predicate that was maybe someone only used this predicate like a year ago, you have to find the transaction a year ago, look at that transaction to get the bytecode. Which is, again, that's it's a good thing because the data is still out there. You can find it if you need to. Like blockchain detectives can still get it, but you don't need like all the nodes in the network to be storing that data.
Makes sense. Okay, we're almost at the end. I wanted to ask a quick question just about scripts. So I know like when I think about the FuelVM, generally I think about like 3 main components: predicates, scripts, and contracts. We've spent a lot of time today talking about predicates, but I just wanted to quickly try to understand what scripts are. How are they different from predicates? Do they like work together? How does all of that work?
Yep, I guess so yeah, about scripts. So basically scripts are, you could say, they dictate what happens as part of your transaction. So in case of the EVM, if someone comes from the world of the EVM, ideally your transactions look like, oh, I want to send X to David, or let's say I want to interact with a particular contract. So either you are interacting with smart contracts or you are interacting with addresses like EUAs to EUAs, right? But then the way Fuel's paradigm work is that there is a transaction have inputs, which means that the assets that I want to spend as part of this transaction, and then there is this another thing attached with it, which is called a script. So without a script, if you have input assets and output assets, then the script is nothing. Then you're basically just sending your funds. So it's basically it's basically normal transfer of funds between multiple parties. But what a script allows you to do is that it allows you to do various other complex operations as part of this transaction. So you could, for example, interact with the smart contract, you could call 5 smart contracts together, and you could do all sort of various things in various orders as part of a transaction. So for example, right now if someone comes from the EVM world, they are very used to this approve. So firstly, they approve to spend an asset, and then they spend an asset. Now, although in case of Fuel, because of native assets, we don't even need the approve. But hypothetically, if someone designs an ERC20 on Fuel, what they could do is that they could say, okay, this is my smart contract. And in the script, the first step I will write is approve. And then the second thing that I will write is spend. And it's done. Like all these 2 operations are done directly as part of a single transaction. So scripts allows you to batch various complex operations as part of a transaction, and they dictate what happens as part of your transaction. So I guess that's the explanation that I have in my mind, but I'm pretty sure David has a better explanation than this because he's usually very better with like explaining things with around predicates and scripts. So yep.
I think instead of an explanation, I think just a good example I like to give is the Uniswap router. So every time you use Uniswap, you router function. There's basically Uniswap has a bunch of pools where the actual assets are held, and then there's this router, and you basically tell the router like, all right, I want to swap, from asset A to B, and I want to swap from B to C, and if the output of that is not enough, this is basically your slippage. If there's too much slippage, then just cancel the whole transaction. And on Uniswap, the router is a smart contract. It's something stored on chain. But it's stateless. It doesn't do anything. It doesn't really need to be stored on chain because it's kind of it's just a set of instructions. So in Fuel, if you're, for projects like Mir, for, any Uniswap type AMM, instead of storing the router, you can just have a router script. You can do the same exact logic, like, swap from A to B, B to C, check the slippage, but it's just part of the transaction itself. And this means when there's a script, like, again, Uniswap is on like they release updated versions of these the router contracts, and they add different functions and things like that. Instead of needing to deploy new contracts and store them permanently forever on the blockchain, you just let the user, update the script that they're doing. You push a new script to the UI. And so I think that's a good example of like what a script does and why it's better than like the traditional way of doing things.
Gotcha. I thought both of your explanations were great. Cool. I don't think that there's anything else I wanted to ask. Is there anything that we want to talk about with predicates that we haven't covered yet? Harsh, you're muted if you're speaking.
Yeah, I was saying that, like, I guess there's too much to talk about predicates. So I guess we could just sit here for hours and we could still be talking predicates. But I guess, like, we did cover a decent bit for people to get started and be intrigued about them. So I guess, yeah, for me, yeah, I guess, like, we talked a lot of really cool stuff about them. But what about you? Like, what's the coolest thing that, because I guess me and David have talked a lot about, like what we like about predicates, but I guess you recently wrote an article about it. So yeah, I guess, like, what's the coolest thing that you have found about them? And yeah, what feature do you love the most about them?
I mean, I just like how simple they are, but how they make everything just easier. I think like we honestly we talked about all the cool features with predicates, but I still kind of my mind is still blown by how they're stateless and they're cheap and they're secure. Like they're doing everything all at the same time, and it just makes me wonder like why aren't more people using predicates? Because I just feel like the technology is really really cool, and it could actually completely change the way we interact with blockchains. Um, but I think the stateless thing is really cool. I know that like state minimization is such a big thing at Fuel, but I didn't even know what exactly, like, I really appreciated your explanation, David, about how like historical state like is still there. I mean, it's obviously not as easy to access, but it's there. But it's more like the current state of things that you don't necessarily always need all that information all the time. And with predicates, like it's kind of like you're only using it when you need to, but otherwise it's a lot more efficient. So I would say like that's like the coolest thing about predicates for me, and also just how it literally has everything. I feel like we talked about the limitations a little bit, but I honestly didn't feel like they were really limitations. I think the biggest thing is just that there's just a well of untapped technology here with a lot of potential, and I'm excited to see where things go with them.
Yeah. So one thing to add, by the way, here is that predicates do exist on Bitcoin in some form, and that is with P2SH, whereas like you can lock your Bitcoins behind a script hash, which is very similar to how Predicate works. I guess what's really unique about Fuel is that we offer a really super cool language called Sway, and we give you like a pure Turing complete system to write your predicates in. So what you can do with Bitcoin and the P2 script hash is way primitive compared to what you can do with what we have at predicates. But yeah, for me, it's surprising as well that somehow there is only Bitcoin and Fuel that have looked into it. But then I haven't also personally seen like any other chain which had something similar to it. So I guess, yeah, like they have historical context, but somehow like Fuel is the only other chain that I know I exist on it. I guess Cardano would also have some version of it, but I'm not aware. Like I don't look much into Cardano. So yeah.
Cool. Okay, I think that brings us to the end. If you guys want more information about predicates and scripts, you can check out our article. It's on our Twitter and it's also on Mirror. So definitely check it out if you want more details. We have stuff in our docs as well. So yeah, anything else to add, guys, before we close up the discussion?
Nope.
I think
I
that was
guess I push.
Covered a lot there.
Yeah, exactly.
And that all of that in 1 hour. Good for us.
Yeah.
Yep.
All right.
Cool. Well,
Thanks.
thanks so much, Tanya, for leading this fun discussion.
Yeah. Thank
Yep.
you.
Thanks,
Bye.
Anya.
Okay.
Yeah.
Yes.
Bye. See you all.